Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for May-June 2023, and the code is 9709/52. Okay, let's get started. Now, question number 1. The random variable x takes the value -2, 2, and 3 is given that the probability of each x will be, the probability of x equals to small x will be k of x squared minus 1, where k is a constant. A. Draw out the probability distribution table for x, giving the probabilities as numerical fractions. Okay, so from here we know that the x will be these three values. Right, so I will write down the probability for each x first. So px equals to -2. It will be k of -2 squared minus 1. Then you will get 3k. Okay, then px equals to 2. It will be k of 2 squared minus 1, which is 3k as well. And then p of x equals to 3. Then I will get k times 3 squared minus 1, which is 8k. Okay, then we use the concept of total probabilities equals to 1 in order to get the k value before we get the probability distribution table. So now I will add up these three probabilities and let it be 1. So now 3k plus 3k is 6k. 6k plus 8k will be 14k on the left hand side, and it will be 1 on the right hand side. Therefore, my k is 1 over 14. So with this, I can just write down my probability distribution table. So probably I write here. So now probability distribution table for x. So it will be the x values together with it's a table that consists of x values and also the probabilities. So now our x values will be -2, 2, and 3. Okay, then the corresponding probabilities will be 3k. So now I will replace the k by 1 over 4. That means you will be getting I will replace the k by 1 over 14. So it means that you will be getting 3 over 14 for the first probability. The second probability also 3k, then it will be the same value as well. And then the last probability will be 8k. Then I will get 8 over 14. So this is the requested probability distribution table for the x. Okay, now B, find the EX and variance x. So the EX and variance x will be counted based on the probability distribution table that we have found. For your information, EX is basically summation x times px. Okay, that means you need to multiply the x with the p first before you add the sum for another pair of the value. So now I will get, based on this table, alright, I will get -2 times 3 over 14, then plus the next multiplication will be 2 times 3 over 14, and the last will be 3 times 8 over 14. Alright, then from here you'll be getting 24 over 14, and hence the answer will be 12 over 7. So we have done the EX. Now for variance x, we need to get the EX squared first. So basically EX squared will be summation x squared times the p. Alright, so now what we need to do here is, this will be the x, right? You just need to square all this and keep the rest. So I will get -2 squared times 3 over 14 plus 2 squared times 3 over 14, followed by 3 squared times 8 over 14. Now, from here, you will be getting 96 over 14. So after you have found this, substitute into the formula, variance x will be EX squared minus square of EX. Alright, so now it will be 96 over 14 minus square of 12 over 7. Then from here, you can leave your answer in fraction, which is 192 over 49, or probably you can just leave your answer correct to three significant figures, which is 3.92. Okay, so we have found the expected value and variance. Now for question number 2. A sports event is taking place for 4 days, beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability that it will rain is 0.7 if it rained on the previous day. Alright, and it will be rain. The probability that it will rain is 0.2 if it did not rain on the previous day. So this 0.7 and 0.2 will be the conditional probability because it depends on the previous day. Now A, find the probability that it does not rain on any of the 4 days of the event. Okay, so before I solve this question, I will write down the values first. So this 0.4 means it will be rain on Sunday, right? So I will write P rain on Sunday is 0.4. Then means that it will not rain. Let's say it's bar is 0.6 because 1 minus 0.4 will be 0.6. Now, the probability that it will rain is 0.7 if it rained on the previous day. So because it starts on Sunday, alright, so from here I will write P rain on Sunday or rain on the previous day, first day. Then it will be rain on the second day. The probability is 0.7. And it will be 0.2 when it did not rain on the previous day. Means that if let's say the previous day is not rain, the next day it will rain is 0.2. Okay, so these are the properties that I have found. Now from here, I will say that if let's say it rained on the previous day, right? So probably I can just write here. If it is rain on previous day, it will not rain on the next day. It will be 0.3. Okay, and probability that it will not rain on the previous day and it is not rain on the next day as well, it will be 1 minus 0.2, which is 0.8 based on all this information. Okay, because when you observe a day, it will be just raining or not raining. Now, A, find the probability that it does not rain. Does not rain on any of the 4 days. Means that now, okay, so P does not rain on any of 4 days. It will be P not rain first day, second day, third day, and fourth day. Okay, so the first day is our Sunday. So if not rains, it will be 0.6. Now we know that all the days are independent to each other. Okay, so from here you can change your times because it is the intersection. So for the second one, we know that the previous day not rain. Okay, then the next day is not raining. So not rain first day, second day not rain, it will be 0.8. So same for the third day. Okay, third day depends on previous day. So if it is not rain on previous day, it will be rain on second day. The next day will be 0.8 as well. So which means all this will be 0.8. Alright, so from here I will be getting 192 over 625. So I will leave my answer in fraction. You may leave your answer in decimal, but it will be up to 4 decimal places. Okay, now B. Find the probability that first day on which it rains during the event is Tuesday. Okay, so when the first day it rains is on Tuesday, which means, right? So, which means the first 2 days, the Sunday and Monday will not be rain. So first day it rains is Tuesday. That means it will be Sunday not rain, okay, and Monday not rain, and Tuesday rain. Okay, so I will say that this is PRS times, you can write like this, Sunday not rain, Monday not rain, okay, times raining on the third day, but then the RS and the Monday and Sunday will not be rain. Okay, so now PRS prime or bar means that it will be 0.6 times, okay, Sunday not rain, Monday not rain. So it means first day not rain, second day also not rain. So first day not rain, second day not rain is 0.8. Okay, then for the last one, means that we know that the previous day not rain, the Monday not rain, but the Tuesday rains. Okay, so it means that the previous day not rain and the next day rain. So when you look at here, previous day not rain, okay, and the next day rains. That means the probability is 0.2. Then I will get 12 over 125, or you can just leave your answer in 3 significant figures, 0.096. Okay, now see, find the probability that it rains on exactly one of the 4 days of the event. Alright, so now P rains exactly on exactly one of 4 days. So it means it will be, let's say, first day rain, okay, and then second day not rain, third day not rain, fourth day not rain. Or it could be first day not rain, second day rains. Then the rest of the days also no rain. Then, or I would say that it will be first 2 days not rain, so the raining will be on the third day, and then followed by the fourth day not rain, or first 3 days not raining, and then the last day rain. Okay, so now you can use the previous method, which is here, to get the probability. So now this means first day rain. So I will rewrite my probability. First day rain is 0.4. Second day not rain. Second day not rain means that first day already rain. Alright. So now probably I will write this. PR1 times P slash R1 second day not rain, times P, probably I write R2 not rain, R3 not rain, times P, R3 not rain, but R4 not rain. That is all this will be same as the first case, which is raining on the first day. Okay, so if you write like this, then you can see clearly. Now plus P, first day not rain, now second day rains. So first day not rain, second day rain, times third day not rain, but the previous day rains. Not rain, previous day rain, times third day not rain, fourth day not rain. So fourth day not rain, given that third day also not rain. This will be the second probability, which means it rains on the second day. Now same for the next one. Not rain on the first day. Okay, here, not rain on the first day. And not rain on the second day. So now, given that not rain on the second day, first day, and then it is not rain on the second day, times P. Now R3 is rain on the third day and not rain on second day. Means that rain on third day, but now not rain on previous day. And the last one is not rain on fourth day, but rain on previous day. So rain on previous day, not rain on the fourth day. Okay, and plus first 3 days not rain. So P not rain and P not rain on second day, given previous day not rain, times P not rain on previous day and not rain on third day and not rain on previous day, times the last one, rain on the fourth day but not rain on previous day. Okay, so this will be the step-by-step working if you write it down all. So now I will just rewrite this. Okay, P rain on first day 0.4. So now I will write down all these summaries. P rain on first day is 0.4. That means P not rain on first day will be 0.6. And then now first day rain, second day rain is 0.7. So first day rain, second day rain is 0.7. Means that now if first day rain, second day not rain will be 0.3. So the total is 1. Lastly, first day not rain, second day rain is 0.2. First day not rain, second day rain is 0.2. That means first day not rain, second day not rain will be 0.8. Okay, so now we will just substitute all these values into these 4 expressions. So the first one is rain. First day rain 0.4. Multiply with, okay, look at here. I'm doing this. Rain in first day, second day not rain, so 0.3. Okay, both day not rain will be 0.8. And then both day not rain will be 0.8. So this will be the probability for first case. Or second case, which is here now. First day not rain, it will be 0.6. Now 2 days also not rain, it will be 0.8. Okay, wait, let me write down, check carefully. Okay, no, I'm not solving this. I'm solving the secondary range. So it means that I overlook it. Just now we have solved this. Now it's the turn for this part. Okay, so first day not rain is 0.6, done. Second, the next one is secondary rain. Given that first day not rain, so secondary rain, first day not rain is 0.2. After that, given that previous day rain, this is not rain. So rain and not rain, which is this 0.3. And then the other one will be not rain for both. Or, okay, now this is the third case. Not rain first day, 0.6. Then the second day also not rain. So it means that we refer to the last probability is 0.8. And then the third one will be, the third one is here. Previous day not rain and today rain. So previous day not rain and today rain is 0.2. Okay, and then lastly, it will be rain on previous day, not rain on the next day. Rain on previous day, not rain on next day. So 0.3. Okay, plus the last one. Not rain on first day, 0.6. Second day also not rain. Look at the last probability here, which is 0.8. Then also 0.8. Lastly, previous day not rain, but next day is rain. Okay, it's raining, so it will be 0.2. Alright, so these are the working. Then now, when you get the total of all of this, right, it will be 0.211, or probably I will just write down each probability, it will be easier. So the first probability is 0.0768. The second probability will be 0.0288, and then 0.0288 plus 0.0768. Then at last you will be getting 0.211 correct to 3 significant figures. Alright, so there is another method to solve this question, which is by using tree diagram. So you can draw the tree diagram and label accordingly. Now for question 3. The following back-to-back stem and leaf diagram shows represents the monthly salaries in dollars of 27 employees at each of the two companies A and B. So this key 1/27/0, let's say here, means $2,710 excuse me, for company A, and 27/6 here means that it is $2,760 for company B. Now A, find the median and inter-quarter range for the salaries salaries of employees in company A. So now, since we know that it will be 27 employees for each company, so now my median, it is Q2, probably you can just write median or you can just write Q2. It will be half of n plus 1 theta. That means it's half of 27 plus 1, which is 28, which is also theta number 14. Okay, so when theta number 14, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. That means the answer, sorry. That means the answer will be 2710. Okay, now to get the inter-quarter range, we need to get the Q1 and Q3, because the inter-quarter range is Q3 minus Q1. So Q1 is 1/4 of the total. Or you can say that it's half of the first half, or it's half of the median. Okay, first half of the median. So from here, I will just use the formula because it can be divided completely. Then I will get data number 7. Alright, so just now I have labeled data number 7 is basically 261 because this is 7. So then it will be 2610. Then now Q3 is 3/4 of n plus 1, which is 3/4 of 28. Then I will get data number 20 first. Okay, so now I will continue labeling the data. This is 15, 16, 17, 18, 19, data number 20, 21. Okay, so obviously my Q3 is 28, 2/28. That means it's 2820. Sorry. My data number 21 is this. So it's 2840. Okay, so the interquartile range IQR will be Q3 minus Q1, which is 2840 minus 2610. Then you will be getting 230. So that's the solution for A. Okay, now the lower quartile, median, and upper quartile for company B are 2,600, or all these three values respectively. B, draw two box and whisker plots in a single diagram to represent the information for the salaries of employees at companies A and B. Okay, so now here I will write down the information that you can see clearly. So basically for company A, alright, median is, I will write down Q1 first. The Q1 is 2610. Q2 is our median. So the Q2, 2710, Q3 is 2840. And then we need to get the minimum and maximum. So the minimum is 2500, maximum is 3010. So minimum 2500, maximum is 3010. Okay, so now this will be the Q1 for the company B. Then this is Q2, Q3. But then we need to know the maximum and minimum for the company B. So for B, minimum, maximum. Alright, so look at the stem plot diagram. This is 2540, 3090. Okay, so now we can start drawing the box and whisker plots. Okay, let's say for example, look at here. The minimum values will be 2500 for A and 2540 for B. Maximum is 3090 and 3010. Alright, 3010. So from here, if this is the plot, right, the diagram or the graph or the grid, right? So from here, I need to decide the scale. So here you have 1, 2, 3, 4, 5, or probably I can say this is 1, 2, 3, 4, 5, 6, 7. So since its minimum is 2,500, so I will start with 2,500 first, right? So here I will label 2,500, and I will use a scale of this whole value is 100. That means the width is 100. So here will be 2,600, 2,700, 2,800, 2,900, 3,000. Then this will be 3,100 to gather all the values. Okay, so now for the A, minimum is 2,500. That means I will draw it here. No, sorry. Minimum should be this. Okay, maximum is 3010. So if the width here is 100, hang on please. Okay, so now if the width here is 100 and there are 10 squares, that means each square is 10. So one square is 10 units, right, or $10. So now I need to mark 3010, which means it will be one square after the 3,000. Right, so these are the maximum and minimum for companies A. Then Q1 is 2610, so 2610, one square after the 2,600. Then 2710, one square after the 2,700. 2840 means 4 squares after the 2,800. So then I will draw a horizontal line to join these three measurements, and then another longer tail to connect the minimum and the box. This will be the whisker. So this is for company A. Okay, so now B, minimum value is 2540. So this is 25. Then it will be 4 squares after the 2,500. So now I will let it be here. Oh no, sorry. This is 2,500. It will be 4 squares after the 2,500. And then the maximum is 2090, means 9 squares after the 3,000, or probably 1 square before the 3,100. Okay, so now look at the Q1. Q1 is 2,600. So 2,600 is over here. Then the Q2 is 2690, means 9 squares after the 2,600. Okay, lastly, it will be 2780, means that 8 square after the 2,700. 8 squares. So 2,700, 8 squares. Alright, so please draw all this using rulers. Using ruler. Okay, so now join the box with the minimum and maximum point. Alright, so this will be the company B. Alright, so we have done the box and whisker diagram, or box and whisker plots for companies A and B. Okay, now see, comment on whether the mean would be a more appropriate measure than median for comparing the given information for the two companies. Okay, so when you look at the box plot here, or box and whisker plots, the mean is used when you are given the symmetrical distribution. Alright, so now when you look at the company B here, company B minimum value is 2,540, but the maximum is 3090, and then the box will be somewhere here, somewhere between 2,600 and 2,800. So there is an extreme value, right? Because the tail, look at the tail here, it is skewed actually, alright? So it is skewed to the right. So when skewed to the right, basically we are using median, alright? So then, even though the company A is almost symmetrical, okay, so I will just write median. Okay, whether or not, okay, comment on whether the mean would be appropriate. So you will just write no, median is more appropriate. Right? Why? Because there is extreme value in company B. So the extreme value is basically referring to the maximum, because all these are almost the same except the maximum. Maximum is too far away from the rest of them. So 3090. Okay. Or you can say that the distribution is skewed. Alright. So hence the distribution of company B is skewed. So for skewed, we always use median. Alright, so we have done this question. Let's move on to the next question. Now for question 4, a fair 5-sided spinner has sides labeled 1 until 5. The spinner is spun repeatedly until a 2 is obtained on the side on which the spinner lands. Now the variable x denotes the number of spins required. So if you need to spin until a 2 is obtained, means that you repeat this experiment until you get the first success. So the 2 is considered a success. Alright, so now you need to spin for 4 times. So from here, I could say that for the probability, it will be geometric distribution. Okay, of course, this is geometric distribution. So x is geometric. The probability of getting 2, alright, is 1 out of 5. That's a probability. So means that probability of success is 1 over 5. Probability of failure will be 1 minus 1 over 5, which is 4 over 5. Then now when px equals to 4, now this means you have run the experiment 4 times. The last one is the success. This is number 2. And it is a first success, which means all previous 3 will not be success. Okay, so now since the experiment is independent, okay, so it will be probability of success, probability of failure for 3 times, because 3 times of not success. So I will get 4 over 5 to the power of 3, and then the last one is success, 1 over 5. Then you will be getting 64 over 625. So that's the solution for A. Now, when px less than 6, so px less than 6, that means it will be 0, no, it will be 1 until 5 because you have to run the experiment at least one time. So I will say that this is p x less equals to 5. Now if you still remember for geometric distribution, x is geometric with p, probability of success, p x less equals to small x will be 1 minus q to the power of x. This is the formula. So from here I will just direct apply. So it will be 1 minus q. My q is 4 over 5 from the previous working. So 4 over 5 to the power of 5. Then you will get 2101 divided by 3125 in fraction. Okay, now next question. Two fair 5-sided spinners. Now it's two. Okay, two spinners, each with sides labeled 1 until 5, no change, are spun at the same time. If the numbers obtained are equal, then the score is 0. If the score is higher, otherwise, the score is higher number minus the lower number. Okay. So now, see, find the probability that the score is greater than 0. So greater than 0 means you won't get equal. And given that means conditional probability slash the score is not equal to 2. Okay, so now I will write down probability, let's say score is greater than 0, given that the score is not equal to 2. Okay, so now since this is conditional probability, then I will use a formula. This will be probability of, now for your information, conditional probability formula is PA slash B equals to PA intersect B over PB. Okay, so here will be score greater than 0 and the score is not 2 over P score is not 2. Now to solve this question, I will draw a table, two-way table. So this will be the spinner 1 and this is a spinner 2. So here I have 5 results. So here again 5. Now when the scores are equal, when the numbers are equal, the scores will be 0. So I will fill up the 0 first, the scores, 0 scores. Alright, so now if you get different scores, then it will be, if you get different numbers, then the score is higher number minus lower number. So 2 minus 1 is 1, 3 minus 1, 2, 3, 4, and so on. So 2 minus 1, it will be 1, higher minus lower. So here is 1, 2, 3. So 3 minus 1, I get 2. 3 minus 2 is 1. 4 minus 3, 1. 5 minus 3, 2. 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3, 1. Then 5 minus 4 is 1. So 5 minus 1 is 4. Then 3, 2, 1. So the numbers inside the tables will be the scores. Right? So probably I will label the original numbers by using other color, then you can see clearly. Right, so now when you look at the formula here, we need score more than 0 and not 2. So when score more than 0 and not 2 means that it will be 0, it will be 1, 3, 4. Okay, so all this will be not 2 and more than 0. So now, my probability for the numerator will be, you just count how many circles. So first column 3, second column 3, so 6. Third column 2, so 6 plus 2 is 8. 8 plus 3 from the fourth column, 8 plus 3 is 11, plus another 3 means that you get 14. Out of first row, I have 5. Then here I have another 5 results for the spinner 2, means 5 times 5, total will be 25. That is my numerator, the probability of the numerator, divided by the score is not 2. The score is not 2 means that it will be including 0 as well. So it means that the existing plus the zeros. So I have 5 zeros here together with the existing 14 circles. It will be 19 over 25. Therefore, from here I will get 14 over 19. Okay, so now for D, the two spinners are spun at the same time repeatedly. Part D, for 9 randomly chosen spins of 2 spinners, find the probability that the score is greater than 2 on at least 3 occasions. Means that now you spin for 9 times. Okay, you need to get at least 3 times the score will be greater than 2. So now I have to find what is the probability that the score is greater than 2. So when the score is greater than 2 means that it will be score equals to 3 or 4. So where all means that now you plus. Okay, so look at the table here, 3 or 4. So when 3, I have 1. 3 or 4, you just take directly, 3 or 4. Okay, so from here, I will have 1, 2, 3, 4, 5, 6. 6 purple color. So it will be 6 out of 25. Alright, so when you look at the question carefully, you run the experiment 9 times. And out of 9 times, you need to get at least 3 successes. So score more than 2 is considered as successes. Is considered as success. So from here, obviously this is binomial distribution. So I will write x is binomial distribution, whereby my x means score more than 2. Okay, so probably I will just define first. Let x be score more than 2. So now my x will be binomial distributed. N is 9 because you spin it for 9 times. Then the probability of success is 6 over 25. So this means P is 6 over 25. So the Q is 1 minus 6 over 25. And I will get 19 over 25. Okay, and now you need to find P at least 3. So Px greater than equals to 3. So when Px greater equals to 3 means that it will be 3, 4, 5 until 9. So I will use the complementation rule, means that 1 minus Px equals to 0, all the previous x. Then Px equals to 1, Px equals to 2. Because you count 3 onwards. Then here, for your information, binomial distribution is x is b and p. The probability will be NCX, Px, Q, n minus x. Okay, so now use this formula to get the probabilities. So I will get, now the first one, x equals to 0 means no success. No success, I will just say it will be all failures. So failures is 19 over 25. And they are 9 because you run the experiment for 9 times. Plus Px equals to 1, then I will start using this formula. That means 9C1 out of 9 times 1 success. So here will be 6 over 25 degree 1. Then 19 over 25 degree 8 because 1 success, 8 failures. Or 9C2, 2 failures and it will be 7 successes. Sorry, 2 successes, and it will be 7 failures. Okay, 9C2 is 2 successes. So from here, you will get 1 minus the total of all this will be 0.62869 if you count the total of the brackets. Then I will get 0.371, correct to 3 significant figures. Alright, so let's move on to question number 5. The lengths of western bluebirds are normally distributed with mean 16.5 centimeter and standard deviation 0.6. A random sample of 150 of these birds is selected. A. How many of these 150 birds would you expect to have length between 15.4 centimeter and 16.8 centimeter? So before you get how many birds, you need to find what is the probability of this first. Alright, so now I will write down W is western, alright, is representing western bluebirds. It will be normally distributed with 16.5 centimeters and standard deviation 0.6. So the variance is 0.6 squared. Now I need to count PW between 15.4 and 16.8. So from here, I will standardize the W. So it will be P 15.4. Now when you standardize, okay, just for information, when you standardize the normal random variable, it will be x minus mu over sigma. So here will be W minus mean 16.5 over sigma is 0.6. Then you change to standardized normal random variable Z or Z. So 16.8 minus 16.5 over 0.6. Then from here, when you calculate, it will be negative 1.833 and 0.5. Now once you get this, the next step is going to sketch the normal graph. So when I sketch, I need to label middle is 0, 1 is negative value, another one is positive 0.5. So the region is bounded by these two lines. Now, what I need to do here is I will write it is the PZ less than 0.5 minus the other probability. So it will be PZ less than 0.5 minus the other one. Okay, then from here, I have to find how to figure out how to find this probability, the Z less than negative, because from the normal table you will be you'll be given PZ less than a positive value. So now I have to redraw another graph to show the negative region. So this negative region, negative 1.833, can be reflected to positive 1.833 in the line 0, because the 0 is a symmetrical line. Okay, so it means that the left region is actually same as right region. So this right region is basically 1 minus the previous, means Z less than 1.833. So from here, I will write PZ less than 0.5 minus 1 minus PZ less than 1.833. Okay, so when you use the normal table, the first probability will be 0.6915 minus 1 minus the second probability is going to be 0.9666. Then here will be 0.6581. So here I give 4 decimal places for the working. But then now this is not the final answer, because our final answer is how many out of 150 birds. So from here, I will say expected number of birds of western bluebirds it will be 150 times the probability that we have just found. Then here you will be getting 98.75. But since the birds cannot be in decimal, I will write approximate to 99. Okay, now the next one. The lengths of eastern bluebirds are normally distributed with mean 18.4, standard deviation sigma. So now let E be eastern birds. So it will be normally distributed 18.4 and standard deviation sigma. So now becomes sigma squared. It's known that 72% of the eastern birds have length greater than 17.1 centimeter. Find the value of sigma. So now P E greater than 17.1 is 72%. So you convert 72% into decimal, it will be 0.72. So now from here, I will standardize the E. It will be 17.1 minus 18.4 over sigma, which is 0.72. So when I simplify the numerator, it will be P Z more than negative 1.3 over sigma equals to 0.72. Now, our special graph. Obviously, negative 1.3 over sigma is a negative value because standard deviation will not be negative. It will be always positive. So, negative 1.3 over sigma. And the probability is 0.72. That means here is 0.72. Now, obviously, the negative value is not available in the normal table. Therefore, I have to flip. So when I flip, it will be positive. So when positive, now I have to ignore the negative sign and just write 1.3. And then the region on the left-hand side will be 0.72. Okay, so from here, I will write P Z less than 1.3 over sigma is 0.72. Okay, now from normal table, I will just write from the table. Okay, so P Z less than 0.583 will be 0.72. So now I will compare 1.3 with sigma. 1.3 over sigma with 0.583 because the rest are the same. So then I will get one conclusion. 1.3 over sigma will be 0.583. Then I can find my sigma. So my sigma is 1.3 over 0.583, which is same as 2.23 when you round up to 3 significant figures. Alright, now the next part is a random sample of 120 eastern bluebirds is chosen. Use an approximation to find the probability that fewer than 80 of these 120 bluebirds have length greater than 17.1. So now I have counted the probability just now, or the probability of greater than 17.1 is given basically. Okay, so I will just write this down. So probability E greater than 17.1 is 0.72. This is basically at first binomial because 120 birds. So from here I will write P equals to 0.72, and then the N is 120. So from here is mentioned approximation. So now I have to decide, right? What kind of this approximation is suitable for this question. So therefore, my NP, it will be 120 times 0.72, and then I will get 86.4. Now my NQ, it will be 120 times 0.28, which is 33.6. Now, both are greater than 5. So when both are greater than 5 means that it will be normally distributed. So at first, binomial, NP is 120, 0.72. Now it will be normally distributed with mean 86.4. Now I need to count what is my MPQ. So MPQ is 86.4. My Q here is going to be 1 minus 0.72, which is 0.28. And then I will be getting 24.192. That is my variance. Okay, so now probability of less than 80. Alright, so it will be x is less than 80. So now remember, at first it is binomial. Binomial is discrete random variable. Then you approximate to normal. Normal is continuous. So from discrete to continuous, you need to consider the continuity correction. Means that now I need to draw the number line. Less than 80, I label 80, but the actual x will be 79, 78, and so on. And then for the continuity correction, you can plus 0.5 to 80, which is 80.5, or you minus 0.5 from 80, which is 79.5. So obviously now your interval will be less than 79.5 to include these two ticks. So when I convert to W, it will be less than 79.5. This is a probability that you need to count. Then now our W is normally distributed, means that you need to standardize it. So 79.5 minus 86.4 over square root of 24.192. Then from here, you will get negative 1.403. So to get this probability, I need to sketch the normal graph. Less than negative 1.403 will be the region on the left hand side. Okay, so here I will flip. So when I flip or I reflect it, it will be positive, and the region now becomes right hand side. So in order to get this probability, it will be 1 minus all the previous regions. So I will just write P Z more than 1.403. Then it will be same as 1 minus P Z less than 1.403. Then now I will get 0.9196 from the table. Then at last you'll be getting 0.0804. Alright, so this is the solution for part C. Okay, now next question, number 6. In a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person completes in only one of these sports. A team of 7 is selected from these 25 people to take part in a competition. Now find the number of different ways in which the team of 7 can be selected if it consists of exactly 1 swimmer, at least 4 cyclists, and at most 2 runners. Okay, so for this, I will draw a table. So at first, you will have 6 swimmers. So 6 swimmers. And then 8 cyclists. 11 runners. Okay, now you need to get exactly 1 swimmer. So exactly 1 swimmer, at least 4 cyclists, then at most 2 runners, means less than equals to 2 runners. So now, if you need to get 1S and to form 7, okay, to form 7 people in a team, so at least 4 swimmers means that, at least 4 cyclists means that here I start with 4, it can be 5, and then less than equals to 2R means that if here 1 and 4 is already 5, to make it to 7, I need another 2. If 1 and 5 is already 6, so I need another R. It can be 0R. That means I can consider 6 cyclists, right? Because total is 8. Now, other than that, you cannot fulfill one swimmer. So now the number of ways, okay, so number of ways, so it means that from 6 swimmers, you choose 1. Okay, the first one, this is the first combination. So 6 swimmers, you choose 1. And for the second case, 8 cyclists, you choose 4. Then 11 runners, you choose 2. So all these are the combinations. 8C2 and 11, 8C4 and 11C2. So this is for first combination. Or the second combination is now 6 choose 1, 8 choose 5, 11 choose 1. So I will get 6C1, 8C5, 11C1. We use a times here because n. Okay, plus is all. Now lastly, 6 choose 1, 8 choose 6, and 11 choose 0. So 11 choose 0, you can ignore it if you want. Right, so here I will not write because I already found 7 people. So the first bracket you will get 23100. Second bracket is 3696. Third bracket is 168. So at last you will get 26964. So this is the solution for A. Now, for another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. The team members stand in a line for photograph. How many different arrangements are there of these 9 people? So there are 9 here. These are the 9. If the swimmers stand together, the cyclists stand together, and the runners stand together. Which means now I will say that 2 swimmers stand together, 3 cyclists stand together, then 4 runners stand together. But then the question doesn't mention that the cyclist must be the first place, second place is cyclist, the swimmer is the first place, second place is cyclist, and the runners in the third place, right? It can be any orders. Means that now the number of arrangements, you need to arrange these 3 groups. So it can be in any orders. So it will be 1, 2, 3. 3 groups. So these 3 groups, when you arrange, it will be 3 factorial. That means you can start with S, C, or R, then in any order. And then now, don't forget that for these 2 swimmers, they are different persons. So now we have to arrange these 2 S. So it will be 2 factorial for the S, 3C, so 3 factorial for C, and 4R will be 4 factorial. Okay, so remember, this 3 factorial is to arrange the orders. It's the orders of the groups, of these 3 groups, right? Then with this, you will be getting 1728 arrangements. Okay, now see, find how many different arrangements are there of the 9 people if none of the cyclists stand next to each other. Means that the cyclists must be separated. So now I have 2S, 3C, 4R. Okay, I have 2S, 3C, 4R. Now, if the cyclists are separated, means that now I will have to arrange this S and C, the swimmers and the runners first. So I have to arrange this 6 person. So I will draw 6 lines, 1, 2, 3, 4, 5, 6 for this R and S. Okay, so then to arrange this, right, I will write number of arrangements. It will be 6 factorial because all these are different person. And then I need to arrange for the cyclists. So now, to make sure that these three cyclists are not next to each other, that means you have to locate the cyclist in one of the arrows here. Alright, so then they will be separated, will not be standing next to each other. So here I have 1, 2, 3, 4, 5, 6, 7. So I have 7 choices for these three cyclists. Therefore, it will be 7p3. Okay, because the arrangement is important. So with this, you will be getting 151200. So this will be the working for this question. This is for cyclists. Okay. So we have done the last question of this paper. Alright. So thanks for watching this video. Please subscribe to my channel if you think that the video is useful. Alright. And stay tuned for more upcoming videos. Thank you. Bye.